Good morning and good afternoon, wherever you are. Welcome to this session on technology to inform climate change resilience planning. I am Gerard Alling, Climate Change Senior Specialist within the American Development Bank and team lead for the bank on the regional track of the Caribbean PPCR for climate resilience. This morning, we had a really fantastic opening session, especially the keynote speaker from Dr. Michael Taylor, who is always inspiring and who can translate really complex information on climate into data or knowledge that everyone can understand. We hope that we'll continue this trend of having this provocative dialogue about the results and the implications, especially for the future. I think Michael's lecture was very, at times challenging, but I think when we look at what needs to be done, certainly looking at the use of technology is going to play a critical part. I'm sure we will also maintain the trend towards having really informative dialogue. In this session, we will be exploring the role that technology has to play in resilience planning, particularly given the activities under the PPCR, where technology, including technological tools, were applied and the implications, as I indicated, for the future. Our speakers are Jayaka Campbell in the Climate Change Study Group at the University of the West Indies, Muna, Emese Landtwing, and I hope I pronounced that correctly, from BSF Swissphoto, and obviously a lot of you know Nichols from the 5Cs. I really want to get into the discussion as quickly as possible. We have 45 minutes, and I want to have sufficient time on the Q&A session. I want to invite Jay to start us off. And Jay he's an assistant lecturer at the Department of Physics at the University of the West Indies, Mona, campus, Jamaica. He's a computational physicist with a focus on atmospheric sciences. His research includes examining the impact of climate change and climate change variability on key economic drivers and social sectors, such as agriculture, water, and health in the Caribbean. Without much further ado, I really want to invite Jay to, as they say in cricket, start us off. You are the opening batsman. Over to you, Jay. And unmute.
Yes. Good day, all. Thank you so much for having me. I am hoping that, I've been given, here we have 45 minutes for the entire session. I promise my other two presenters I will not be using more than 10 minutes. So I'm hoping that leaves enough time for the Q&A. So I've been asked to actually give you a presentation on one of the tools that we've actually designed. You'd have heard from a presentation, the prior presentation from Dr. Ranking about the tool we've designed. And you'll see a common thread coming out in the tools we've designed. And the common thread is we've made it easy. We've made it seamless for persons to use. You require little or no prior expertise to actually use the tools. So the tool we're going to be talking about today is called CREST. Before we get into that, I must tell you that my presentation is going to actually try to describe already existing climate tools from the globe, from the region, so barriers, and then we'll actually describe CREST. So my presentation will be the ABCs of the tools within the region. So getting to the already existing tools. So globally, there is the ESGF. You can actually access all SRES, RCP, SSPs, SRM, and forgive me for using so many acronyms in one go, but these are just different kind of scenarios and different kind of future realizations. But you require some bit of technical expertise to actually go for what you're looking for, process that data for your country, and actually get your results. You can actually alternatively use KNMI, and this is, again, forgive I got another acronym, but they do facilitate you having to know they produce very maps for your country, but with some limited functionalities and some limited scopes. And there's some other data repositories. Regionally, we have the 5Cs data clearing warehouse. and they do host SRES and RCP data, but this is all from Précis. There, you can actually email requests to INSMET, the CSGM group, or other members within a Caribbean modeling consortium to get some data. But this sometimes tend to be cumbersome, and that leads us to the barriers that exist within the current set of tools. It's largely geared towards scientists, so persons that have previous or prior knowledge in actually knowing how to process the data, use the tools. Within ESGF, there's no ability to limit the extent of the domain from you have to download everything and then limit to the area or domain of interest. And for the 5Cs data clearinghouse, there's no extremes possible, and there's limited plotting functionality. So enter CREST. What is CREST? CREST is the Caribbean's regional ensemble sharing tool. What it's geared at doing, it's an online platform for geared at providing simplified access to the latest regional climate scenarios. And these are geared towards just the Caribbean context. Access allows for plotting of graphs and maps, also includes calculations of extremes, as well as, it does not require the expertise for you to know that I'm looking at a netcdf file. I need this to process my netcdf file. I have output coming out in this column. You don't require all of that. And this was an open source tool that was originally developed by Climate Analytics, and we've taken it and retrofitted it for the Caribbean. So when you get to CREST, you get this nice landing page that's focused on the Caribbean. I've dropped the URL there, forgive me, but they say when you actually, most needed technology tends to fail. So you may have a slight difficulty accessing the link just now, but we promise you it will be available soon. All right, so the data sets that we have within CREST, there's an historical data set, and we try our best to use things that are, available publicly and, would actually represent the region well. So what happens is that it's called UMB, and it contains several reanalysis and observed data set. And we've actually included the citation for it. There's a global coverage larger than much of the Caribbean islands, but it's still a data set that gives an overall view of what the overall Caribbean, the state of the Caribbean's climate is done. And this data set is used for bias correction, as well as for the representation of the reference climatology. So we're having that historical base and we have something to compare it to. For the future data, much of the future data that we've inputted actually is premised on downscaling using RegCM. So there's a Hadley Center model, there's CNRM and CAN-ESM. But even though I've listed all the things that we've downscaled within those three models, the CREST tool largely focuses on RCP 4.5, and it's confined to a domain over the Central America and Caribbean. And it's at a grid spacing of 0.22 by 0.2, or about 25 km to 25 km. So it's a little more towards the scale of the Caribbean, right? So a bit about the plots that you see. Their maps will be for a reference period. There'll be maps for projection, and any map or any image that you see there can be saved as either PNG or PDF. And any data that's there as well, you can also download the data to do your own plotting if you want to. So if you're a GIS specialist, you can download the data, which is georeference, and you can plot that data as well. Graphs, there's an average transient and average annual cycle, and the graphs as well can be saved. When we talk about that reference period, the maps and plots that you'll see for the reference periods are all based on this UMB data set, right? And for temperature indications, hotter regions are darker than the cooler regions. For precipitation, wetter regions are darker than the drier regions, right? And for the future period, there's a difference between the projection and the reference period. And I know I'm talking without a lot of images, so you may be lost in my words. So in my next slide, I promise you, this is what the tool looks like. And I'm using Haiti as an example. And what you do very quickly is that you select a country, and we have a drop-down list of countries. And currently, there's Dominica, Grenada, Haiti, Jamaica, St. Vincent, and the Grenadines. Right? So there's a drop-down list of countries. You don't even need to specify long and lat. You select a country and the data is available, right? You select a variable, and the list of variables we have currently there would be precipitation, temperature. We even included hot extremes. And we have what is called wet extremes and 5-day wet extremes. So this in a baseline period, the first map you see is for that baseline, that reference period. And again, as I said, you can now actually, just from a click, download the data. As soon as you get to the page, you will actually have the ability to download data. Once you select your country, you set your bias correction period or your reference period, and you set your future period. Once you press that select period, it will generate all the plots for you, right? And as I indicated before, you can download this as a PDF or a PNG, or you can download the data itself. Sir Moderator, how am I doing on time? 2 minutes. All right, good, good. All right, so this is again for monthly values. Now on the same page, you don't have to do much. On the same page, the period of interest you selected is also there, that future period. So you're looking at the 2031s to the 2050s. And what the tool does, in order to ensure that you have the best state, ask you to take a 20-year time slice, and you're looking at that 20-year time slice, not a single year, but a 20-year time slice. And immediately you can see, if you were to compare the two things, you can see where changes are inherent for temperature. You can see that they're to the east and to the south of Haiti, you're projecting warmer temperatures, right? And just to show you that the tool not just works, but the massive islands or massive land masses within the Caribbean. We've selected Jamaica, and this is for precipitation. So at that 25 km resolution, Jamaica actually is represented by a number of grid boxes. And you can see that there again, if this was a global model, Jamaica may be just represented by a single grid box value. And you can see changes going from east to west and north to south across Jamaica. And this is again for the baseline period. It's telling you that there's wetting. You have that wet zone just between St. Mary and Portland. That's the grid box to the east. All right. Now looking at the future period, again, it's not the same. All right. You can see that you can have some areas of wetting, you have areas of drying, and that is that. So the tool is pretty simple, pretty intuitive. A few clicks and you have the data present. We're looking to add additional data. So we're looking to add wind data, relative humidity, and other variables, and all the variables will be produced in the same fashion. Right? Now, for the transient plots, and talking about those those line graphs, right? We try our best to provide you with an ensemble mean, which means you're not just getting projections from one RCM or one GCM, you're getting a suite of them. So within that, you can see where it is that you fall. So again, results are presented for 20 years. So that lightly shaded green box is suggesting to you that's a suite of projections. And that bold line is saying to you, here's where your model falls, right? Or here's the mean of the overall model. Right? We could have done the same thing. And again, looking at it regionally, and then this is for temperature. The top map is for the reference period, all right? And the RCM projections, and then an RCM data. And then, come down to the bottom, and that gives you the projected change. So there's a model data over the same historical period and the UMB data set. And then the bottom one says to you, here is my projected changes. And here we're showing you temperature. And this is if you have a full suite. But we realize that within the region, because of resource constraint, and I have one more slide to show, because of resource constraint, we don't always have that wide range. So we've even done this if you have a single realization. So it doesn't matter if you have the full suite, we will still give you, even if you only have a single projection of a GCM. And again, how to use the platform: select a country, select the climate indicator, select the reference period, you set the projection period, you click select periods, it generates the maps for you, and that's it. Additional work to add additional climate indicators. We're working on sub 10 km runs, which will give you more detail for the region, expand to include other RCMs, which is work ongoing, and expand to all the Caribbean nations. And with that, I thank the University of the West Indies, the PPCR team at Maury, SIF, Climate Analytics, IDB, and everyone for making this all possible. Thank you.
Jay, thanks very much. That was very informative. We will we'll respond to the questions, I'm sure, a number of coming, and I already have some on my own, but we'll take that at the end of all the presentations. I want to go over to Emese for her to present on LiDAR, on the use of LiDAR. Emese is a business development manager at BSF Swissphoto. She has a background in geoinformatics and geodesy. She's a remote sensing and mapping expert, and she will, as I said, will speak on LiDAR as it relates to bathymetry and sea level rise and the implications for climate change and planning along the coastal areas. Emese, over to you, and please unmute.
Thank you very much, Gerard. I'm not sure can you see my screen?
Yes, we can.
Great. So thank you very much for the introduction, and good day, everyone. Thank you very much for joining us today. Within the next 10 minutes, I would like to give you a short introduction about LiDAR technology and how it can help us in resilience planning. So first of all, LiDAR, I'm not sure that I don't know if everybody knows what LiDAR technology is. So let me summarize. What is LiDAR? It's a remote sensing technology, and it's a shortage of light detection and ranging. With this technology, we can acquire information on features of the Earth's surface without physical contact by sending a laser pulse. This allows us to make measurements and acquire much more data than otherwise would be possible. So I'm sure that a few of you know how it is to go out and measure by GPS or with drones. Maybe nowadays with drones very sexy and everybody would like to have it, but with the drone you can only collect a small part. So with the LiDAR technology you can go and cover bigger areas, and it allows us to have a synoptic view of large areas. It can be the coastal zone, it can be a town, it can be a region, but it can be the whole country, whole Europe. So it's really, it gives us the possibility to measure in a very short time a big area. And we can gather this information without exposing people to dangerous situations, without accessing remote areas. So, firefighting areas which are flooded, or military areas where we can't get in. We could use the LiDAR technology and do the measurements there with it. There are different ways to collect with LiDAR technology. It can be a smaller LiDAR, and we can use it from the ground. We can put it on an airborne platforms, so we can put it on an airplane, on a helicopter, on a drone. But it can be also from space, like satellites. And maybe a few words how it works. When we use a LiDAR system and we put it in an airplane, then we are talking from airborne laser scanning, or even if it's a helicopter, if we put it in a platform for flying, then we talk from airborne laser scanning. And airborne laser scanning is the most commonly available LiDAR data. Using this technology, how we use this technology. For airborne laser scanning, we need a LiDAR system. We put it in an airplane. We need also an airplane. Then we need the GPS and an IMU system. IMU and the GPS is measuring the orientation of the system when we are flying. Using the GPS, we know the exactly position of our airplane, and so we know also the exactly position of the system. The system sends out a laser pulse, and when it meets the ground or a surface, then it reflects back. And with time measurement of the pulse time between sending out this pulse and coming back, we have the distance between our system and the ground. And because we have the GPS on board, we know exactly the coordinates, and we can also calculate using these coordinates and the distance measurement, we can calculate the coordinates of the point which sent back the pulse. And so at the end, we get a lot of points, a lot of measured points from the ground, from vegetation, from buildings. And I don't know if you can imagine, but we have between 1 to 20 points in each square meter. So at the end, we have millions, billions, trillions of points. And every point has a 3D coordinate, so X, Y, and Z. And when we send out a pulse and we meet a tree, then a part of the pulse will be reflected from the first surface it met. The rest will go further down and will meet maybe a second leaf, and we'll send also echo back from the second leaf. And if you imagine and you are standing in a forest and you look look up, and if you see light, then with this technology we can be sure that we will have also reached the ground, and we have also measurements on the ground beneath the trees. And we are talking, or we know we use two different types of LiDAR scanning. One is the topographic LiDAR. It uses infrared wavelengths. So with this LiDAR scanner, we can measure surfaces, trees, buildings, and so on. And the second one is the so-called bathymetric LiDAR. This uses a green wave, and with this we can measure also seabed. So it goes down, it goes into the water and measures also seabed. And well, what are the products? As you can imagine now, maybe at the end we have a point cloud. We can calculate this point cloud because we have the GPS information. We can calculate this point cloud in a coordinate system we would like to use. And then we call it georeference point cloud. This means we know what kind of coordinates these are. From this point cloud, we can have a look and define the so-called ground points. We can also classify it in building points, in vegetation points. And using these three kind of points, we can calculate the so-called digital surface model. So elevation models, I'm sure you heard about it. The DSM would be the surface model, including the buildings, including the buildings and including also the vegetation. And if we use the ground points, only the ground points, then we have the terrain model. This doesn't include any vegetation, doesn't include the buildings. And from this DTM, we can also calculate contour lines. So if you are hiking or walking, then you maybe use the maps where you have the contour lines and you see how many meters you have to hike up. This is the contour line. So you can get great contour lines using this LiDAR technology. Okay, then the tin, and we can also calculate 3D models. So city models also using the DSM and the DTM. And if we have also image information, then we would have a textured, nice 3D models. Bathymetry. I already mentioned that using the green wavelengths, we can measure also the seabed. In Caribbean region, we come down up to 30 meters, which is great because in the Caribbean region, the water is clear. And if the terrestrial and the bathymetric LiDAR data is combined, then we have a completely ground or elevation model, and also in the overlapping area to reach an overlapping in the overlapping area and to make sure that we have also in these areas between topography and bathymetry or water line, that we have a good water line. It would be the best to fly the topographic LiDAR data during high tide and the bathymetric LiDAR data during low tide. And another possibility is to combine this sounding data, which is mounted on ship. The system is on ship and they can use the sounding data, and you can combine it with the bathymetric data and you can get a complete seafloor model. There was a pilot program for climate resilience in Jamaica and also for the 5 countries. Gerard was already mentioning, I think. within this pilot program in Jamaica and Haiti, 3 coastal zones were collected using LiDAR technology, topographic and bathymetric LiDAR data, and also aerial images. Here you can see a short overview from the regions measured. I'm not sure how many time do I have? 1 minute. Okay.
1 minute. 1 minute.
Then the geodata, Jamaica, Haiti, are also different. It's the digital surface model, terrain model, seabed model, then the orthophotos, and I will go further. And maybe the most important slide is how LiDAR helps us for climate change resilience planning. Well, basically with this LiDAR technology, we get a very good up-to-date geo information. This data is the base for a lot of applications. And it can be used for climate change analysis related to sea level rise, for storm surge, tsunami impact, risks and impact of landslides. We can use it for flood modeling and putting designs in place to mitigate the impact of flooding, for natural hazard mapping, for land use planning, but also for transportation and infrastructure planning. It helps us also to assess the health of the surface of the seabed, because using the bathymetric data, we see also the coral reefs. And for change detection, if we have two data sets on different time intervals, then we see also changes. So it's for monitoring. Here an example for flooding. Then also in vegetation analysis, another example. I will go through a bit quickly. Tree inventory.
I think you actually have run out of time. But I think we may have to jump to Keith, or maybe 1 or 2 closing remarks from your side, Emese, please.
Yeah, so I chose 2 examples, flood simulation. So if you have the elevation models, then you can have a flood simulation and see if a storm, or if the sea level rises, which buildings are in danger, for example. Are there bridges which are in danger, which people have to move and maybe build somewhere else, the building. Vegetation analysis is something add-on. I think that's not so interesting maybe in this climate change program. Yeah, and here I have an overview. Fields of application, it's big. But yeah, so I almost did it. Sorry for the delay.
No, but I think it's a good jumping off point, especially looking at risk related to flooding, related to sea level rise, because I know this is something that Keith is going to be talking about related to the sea coral tool. So it's a really good segue to Keith's section. And Keith Nichols is a national from St. Lucia. He has a degree from the University of West Indies, from Dalhousie, and from the University of Rhode Island. He has a background in marine fisheries biology, coastal resource management, law of the sea, marine resources use management, sustainability development, and climate change. Quite a mouthful. But especially, I like the fact that all of this relates to the blue economy. So Keith, I think this is a very apt time for you to come in and speak about sea coral. Over to you, Keith.
Thank you, Gerard. And I'm sharing my screen. Let me know if you could see it.
Not as yet.
Screen 3. Oh, share.
Yeah, sure, yes. I got caught. Yes, and we can see it now. Thank you very much.
Great, thanks. Okay, so thanks, Gerard, for the opportunity to share some information on sea coral. And it is pronounced sea coral, the Caribbean Climate Online Risk and Adaptation Tool. Now, I will breeze through some of the background of sea coral, but in 2009, CARICOM heads had approved the regional strategy for addressing climate change and its impact on development. And of course, the implementation plan associated with that strategy, which sort of gave rise to the consideration for developing a risk management ethos in decision making. And this, in a sense, was the genesis of sea coral, essentially geared towards providing an online support system to enable climate resilience decision-making, to help users understand what climate change really is, particularly decision makers in the public service, in government, and other users as well, and how that will impact on our day-to-day activities. And also to help users apply a comprehensive risk assessment and management process to all the activities. So this was the primary drivers of CCORAL. Overall, to support the climate compatible development within the Caribbean, and also to embed considerations of climate change across the entire spectrum.
Donc, ce sont les objectifs de soutenir le développement.
But developed for the Caribbean, by the Caribbean, and it is a homegrown tool. So it is intended to be used by all. Primarily, initially, it was intended to inform decision-making housed within the Ministry of Finances in the countries, Ministry of Finance in the countries, but also for any user who would feel a need to evaluate the climate influence on their own particular activity or vice versa. So CCORAL is actually based on 5 pillars. And you remember from Jay's presentation, there is a home page where you enter CCORAL. It is on the climate change, the 5Cs website. You will select your country, and I wouldn't go into the details of what this does, but speak more about CCORAL overall. There is the entry page where you select your country through a variety of means, but the second column, or the second pillar here, is what's called the screening exercise. That screening exercise allows for high-level determination of the influence, excuse me, of climate change on a particular activity or vice versa. And that then, if the level of climate influence is high, advise the user to do a more detailed analysis using the third pillar here, which will investigate the impacts on legislation, on national planning, a strategy, a policy, a program or a project, or budget preparation or evaluation. These are all the processes in government. There is no other activity that falls outside of those areas. And each of those areas within CCORAL is informed by a specific series of steps and stages that draws out the issues relating to the climate influence. To complete the entire process. And the report is prepared or generated by CCORAL. And CCORAL is heavily dependent on data and information. And the last 2 pillars, where you see the end-to-end CRM processes and the toolbox, are all data. It's an amalgamation of data and tools that are embedded within CCORAL itself. And that allows the user to get information either on the level of climate influence or on the tools the tools that are necessary to inform their own decision making as well. So it's an amalgamation of tools within one tool, which means that CCORAL is always growing. We always need to ensure that it's populated by all the relevant information for all the key sectors. Jay made mention of the Regional Clearinghouse, which is the largest repository of climate information in the region, and CCORAL, of course, uses that as an additional source of information to facilitate decision making. But the data requirements are high. CCORAL is heavily dependent on information for all the sectors. So we have we've strengthened CCORAL with information relating to water resources management, and that is very comprehensive in our view. But CCORAL, because it's relevant to all the sectors, it requires data for agriculture, for industry, for tourism, for coastal resources management and forestry management, all the particular sectors. And we at 5Cs need to find the data pertinent to those sectors that we would populate, we use to populate CCORAL to make it even more relevant to the determination of climate influence in those sectors. So data is, we always need to be growing CCORAL with that data. There was a study done on the utilization of tools within the region. This was done in 2018, and it was found that CCORAL was the second most used tool among decision makers, which is encouraging to us in the region because we really want to ensure that we inculcate a risk management ethos in decision making across the spectrum of agencies, ministries, entities within the Caribbean. And we want to promote the path that's been taken by St. Kitts and Nevis and Grenada, where in the case of St. Kitts, sea coral, the application of sea coral is required as a condition for approval of projects by the Ministry of Economic Development. In Grenada, sea coral was embedded in the Public Finance Management Act of 2017. So it's now owned by the Ministry of Finance, which means all submissions of projects and programs to Grenada must demonstrate the application of sea coral before it's even considered for approval. So even while it's meant to be user-friendly, we still need to embark on training. And fortunately, we've trained to date over 600 persons over the last few years, supported by a variety of agencies. And we are about to roll out, and of course, we did training in Jamaica, which was funded by PBCR. This was just ahead of COVID-19. And we're about to roll out another series of training, possibly online training, under the EU GCCA Plus project that will improve the number, increase the number of persons who have been trained to date. So sea coral is designed to be user-friendly, is designed to be applied to all situations, not only for public decision-making, but for users in all facets of society. And we continue to roll out training. We're developing right now a module, an online module to facilitate greater reach and penetration of individuals. So it's important for everyone to understand that the importance of addressing the risk, climate risk to all activities is key. And I want to end with a statement here. The climate change is everything. It'll impact every facet of our society. However, not everything is climate change. Climate change gets blamed for lots of things for which we as people are responsible. And so we need to embrace that in our whole thinking of how we build resilience across the spectrum of activities within the Caribbean. Thank you. And that's it for me.
Okay, thanks very much. And thanks for keeping within time, because I think we have at least 4 minutes to respond to some questions. I know there are a number of questions within the Q&A, and I'm hoping that, well, I'm going to ask for those questions related to CREST, related to LIDAR. If I saw that Emese was typing some questions, if you can type some of those questions, because some of those are specifically related to the functions of CREST, functions of LIDAR. But I have a sort of general question for the three of you all, and it's something that Keith, you just mentioned. The incorporation of these tools, or the use of these tools, as you mentioned, the example of St. Lucia with, or St. Kitts, sorry, with sea coral being utilized as part of the decision-making process. My big question for three of you is, how do you do this? Because this relates to a theme or an issue that Michael raised in the plenary about the future, about adaptable, about adaptation, mitigation, education, communication. How do we do this? How do you get to that point of saying, this is what you need to utilize? These are the tools. Bring them into your decision-making. I just want to hear your quick thoughts on that, because again, at the end of the day, you have all these tools, and I think somebody had asked that about limiting the potential of these tools. How do we incorporate them more fully into decision-making and planning?
If I may jump in quickly, and using the example of St. Kitts and possibly Grenada as well. In the actual training exercise we conduct, we use a case study. The case study is based on a nationally critically important activity, something that has resonance with decision-making in the country. And what we did was we invited the participants to do an evaluation using sea coral. Then we invited decision makers, senior decision makers, permanent secretaries, ministers, very high-level persons within the spectrum of decision-making within the country, to a presentation which is done by the participants of that particular country. And it was the same approach used in Grenada, where the senior-level decision-makers were invited to the presentation by participants to share with them the findings of the detailed analysis, which is done by their country participants themselves. And that was enough to sway that decision making. They understood at that time, because not only was an opportunity to share knowledge and information, to get them understand what it is they were dealing with, but it presented the decision makers with an actual case of relevance to decision making within the country. And that resonated with decision makers, which prompted the case of St. Kitts. The decision was taken following that presentation that all submissions, the Ministry of Economic Development, would need to demonstrate application of sea coral. So it was an instant response to the presentation. So the key thing is to ensure that you engage decision makers to get them to understand what this is as part of the knowledge building process.
Great. Jay or Emese, maybe you want to chime in here? Okay, Jay first and then Emese.
All right.
Sorry.
I do agree.
Jay first. Sorry.
Yeah.
My bad.
I do agree with Keith. That's one approach that can be taken. Another approach that can be taken is, and this again requires a multidisciplinary approach. If you're, the question extended itself to including the private sector. And, for the private sector, they respond to economics. They respond to a value figure that's added to something. So if there's some, if the tool in any way, shape or form indicates a possible change that has a value attached to it. Let's say you take, for example, an agricultural sector where you can actually, after validating, actually prove that, with the case of Accept that Dale presented, that I can say to you, given the forecast that exists, this is an above normal or average rainfall season. If we take that and input that into the model that's looking at your yields at the end of it, and you take what that produces, for a number of seasons, and you say, well, it's 95% accurate, or we have a 95% confidence. It simply means that given the forecast that's occurring, you can now say, if you plant X, your yields will be affected by this much. And that can also inform insurance and inform other things. So it has to have a dollar figure attached to it for that inclusiveness where private sector is concerned. Where the government is concerned, I agree very much with Keith, but to get to the point of actually including the private sector, it has to have that dollar figure attached to it. And that's my addition. And
I mean, this is a good jumping off point for you as private sector. If you can provide your input on this or your perspective on this.
I'm not sure I will answer the question directly. When I'm thinking about LiDAR data for the private sector, it can also be used for different infrastructure planning, for example. So I'm sure also maybe on St. Lucia or also in Grenada.
Saint Lucie or Grenade.
They can use such data also to see where do we have place to build a power line, where do we have place to build a railroad or streets. So different sectors can use this data.
No, I think what the general sort of trend is the use of or the demonstration of the technology examples, whether it's St. Kitts, whether it is what we saw with Jamaica and Haiti, whether in case with CREST, of being utilized with the 6 countries, and now Jay, you answered the question on expansion. It is having these examples and being able to well, in the case of the PPC, piloting these examples. It's part of the way of disseminating or sensitizing people about the use of these tools. And so we need more examples. We need more case studies. We need more applications, not simply applications for academic purposes, but to respond to, as again, I'm pulling from Michael, in our context, to issues related to the context, whether it's the Caribbean, whether it's Africa, whether it's in the Pacific, to this context, how these tools actually can be applied and their usefulness. We need more examples of this. Ladies and gentlemen, thanks very much. I know we have run out of time and we have to back into the plenary for final remarks. I know some of the questions, we have gotten to most of them and some of them being answered. I really appreciate the speakers, their perspectives, and your involvement. And once again, we look forward to the rest of the workshop, and we will continue this dialogue, I'm sure. Thank you very much.